Hello. In the last video, we have modeled the structural aspects for the Arbiter case study. And in this video, we will be modeling the behavioral aspects for the Arbiter case study. So to model the behavior of Arbiter case study, we will be using the state machine diagram. So to create a state machine diagram in the model we have created for Arbiter case study, just go to the model explorer on the left side here, then click on the SysML model, then right click on the model, SysML model you've created, then new diagram, and then go to UML state machine diagram. Okay, then it will ask you for the name of the diagram. I'm naming it as behavior. You can name it whatever you want, behavior, and okay. Now the state machine diagram has been created. Now you can resize the state machine, the default state machine. Okay. Now you can also rename the state machine as whatever you want. Go to rename the state machine, the default state machine, select the state machine, and then go to the UML tab in the properties section here. And then in the name section you can name it as whatever you want. I'm naming it as Arbiter behavior. Arbiter behavior, and okay, the name has been changed to Arbiter behavior. Okay, so to model the behavior, first of all we will basically take the states of the Arbiter case study. So we have already said that in the last video, in the structural aspects video, we have said that the Arbiter controller basically have 7 states. So to model the states, one is idle state, 3 master, and 3 respective masters idle states. So to model the states, to go to the right section here in the palette, search for state, here it is, and just drag and drop it onto the state machine here. Okay, the state has been created now. It then asks you for the name of the state. I'm naming it as idle state, and okay, the idle state has been created. Okay, now there is another state called as master1 state. So similar, in the same fashion, here in the palette is the state. Just drag the state onto the state machine, and this is basically the master2. Okay, then you can also resize it a bit. Okay, then there is another state called idle2, the idle state for master2. So similarly, the state in the palette, just drag the state onto the state machine here. It will then ask you for the name of the state. I'm naming it as idle2. Okay, so now you can also resize the state here. Okay, now there is another state called as basically the master1 state. So to add a state, go to the palette section here, just drag the state onto and drop it onto the state machine here. Okay, I'm naming it as master1. Okay, you can also resize it. Then there is another state called as idle3 state. Here, then in the same fashion, just drag the state from the palette onto the state machine. And the name of the state would be idle1. Idle1 is basically the idle state for master1. Okay, and then there is another state called as master3 state. And then there is another state called as idle3 state. The same fashion, just drag the state from the palette onto the state machine. Okay, this is basically idle3 state. And okay, okay, so now we have to take the initial node, which is basically necessary for the start of any behavior. So the initial node is here inside the node section of the palette. Here it is. Just drag and drop it onto the state machine diagram. Then we'll then ask you for the name of initial node. I'm not using any name for the initial node. Okay. Okay. So I'm just repositioning the states I have just created. Okay. 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 So now first of all we have to use the transitions between the states in order to kind of depict the flow of the behavior, that how the behavior is, how the behavior will move from one state to another state. So for that we need transitions, and transitions have some guard conditions and trigger conditions on them. So it will be clear when we will be using the transition. So first of all, we need a transition from the initial node onto the state from where the behavior will start. So to add a transition, the default state of the system would be the idle state here. So this will be the initial state for the behavior. To add a transition, go to the edges section of the palette here. Here's the edges section. Here is a transition, and select transition from the palette. Then drop it onto the element from where you want the system to transition from that state to the next state. So I want to drop it on the initial node, because the behavior will start from initial node and gets into the in its default state called as idle state. Okay, now the transition from the initial node cannot have any guard and triggers, so it doesn't have any guard and trigger conditions. Now when the behavior will start, the system initially will be in idle state. Okay, now we need now it can, from idle state, it can go to either master 2 state, master 1 state, or master 3 state. It can go to any of these 3 states, but it cannot go to idle 3, idle 1, or idle 2 states. So now we need a decision node, because it can, from idle state, it can go to any of these 3 states depending upon the conditions. So for going to master 2 state, it has different condition. For going to master 1 state, it has different condition. For going to master 3 state, it has different condition. Whichever condition will get true, the system will jump to that state. So for that purpose, we need a decision node, which basically have multiple outgoing transitions, and only one transition will be selected on the basis of the condition which is true at that time. Okay, so to add a decision node, go to the node section of the palette here, search for the decision node. Okay, here it is, choice is basically the decision node here. Okay, select the choice here and drop it onto the state machine diagram. Okay, it will then ask you for the name. I'm not using any name for this node. And okay, so the system, now we need some transitions. So to add transition, go to the edges section of the palette, select the transition, and I want the transition from idle state to the decision node. Okay, now it is important to note here that the transitions incoming to the decision node cannot have any guard or trigger conditions. Okay, no, sorry, it can have some, it can have guard and triggers. Okay, now this transition will be, the system will exit from the idle state upon reset. Now it is important to note here that in this case study, in this particular case study, we are dealing with active low signals, which basically means that when the reset is active low in this case study. When the reset is 0 or false, then the system will get reset and come back to the idle state. And when reset is 1 or true, it actually means that reset is not working. So the system will come out of the idle state whenever there is no reset, or in other words, reset is equal to true, because when reset is equal to true, then reset is not working at that time in this particular case study, because reset is active low. So this port is basically has a trigger of reset port. To add a trigger, select this transition, go to the UML section of the properties here, then scroll down. Here is the trigger section, then click this plus button. It will then ask you for create a new trigger. I'm triggering it on a port. So to add a port, click this button here. It will then ask you to browse the port. Okay, here is the reset port. Select this reset port, then click this forward arrow button and then click OK. Now it is here in the port section and click OK. Now your trigger has been created. Now it is triggered on the reset port, but the condition on reset port is that when reset is true. So to add a condition on this transition, select this transition, go to the UML section of the properties, and here is the guard condition. Click this plus button. It will then ask you for multiple constraints, time constraint, interval constraint, or duration constraint. Select the simple constraint. A new window will come up. It will then ask you for the constraint element. Click this button. And then constraint element is basically the reset signal, the reset port, sorry. Then select reset port, click this forward arrow button, and then OK. Then specification will be literal boolean true, and OK, and OK. Now it is here in the all true. Okay, now from the decision node we can have multiple transitions, either to master 1, master 2, or master 3. Okay, now to add a transition, select transition from the palette here in the edges section. Here is the transition. Select the transition. Then I want the transition from decision or choice pseudo state to master 2. Okay, and then you can basically reshape the transition. Then there can be another transition from decision node to master 1. To add a transition, go to the edges section of the palette. Here it is. And here from decision node to master 1. Then there can also be another transition from decision node to master 3. Here is the transition. Okay, select the transition from the palette. Then from decision node to master 3, and the transition has been created. So this is kind of behavior. Okay, now these outgoing transitions from decision node will be having some guard conditions upon which it will decide on which transition to take. So first of all, we will be using this transition, which is basically going to master 1 state. This master 1 state has a condition that whenever there is a request from master 1, whenever there is a request from master 1, then this transition is selected and system would go to the master 1 state. So to add a trigger to this means that the system will be triggered on the request 1 port, and the condition on that port is that request 1 is false, because request 1, request 2 and request 3 are also active low, which means that the request will be considered true when the request 1 is false, which means or in other words, when request 1 is false, then there is a request from master 1. Similarly, when request 2 is false, then there is a request from master 2. And then when there is when request 3 is false, then there is a request from master 3. And when request 1 is true, then there is no request from master 1, and vice versa. So this condition has this transition has a condition that when there is a request from master 1, so to trigger it on the request 1, select this transition, go to the UML section of the properties, scroll down here, and then click this button. This is the trigger section. Click this button and browse for the port you want to trigger this transition on. Now browse your SysML model. Here is the reset port, request 1 port. Select the request 1 port, click this forward arrow button and click OK. Now it is shown here in the ports section, and click OK. The trigger has been created. Now the condition on this port is that request 1 should be false. So to add a condition, here is the guard section in the UML properties tab. Click this plus button, add constraint only. Then the constraint element, click this button, and then browse in your SysML model request 1, because there is a condition on request 1. And then select this forward arrow button and OK. And the specification would be literal boolean false. OK. Now let me tell you that in this particular case study, you have to set the default values of request 1, request 2 and request 3 as true. So by default, the boolean ports are taken as false. Their default value is false. But in this case study, you have to take the default value of these 3 ports as true, because the system is working on active low requests. Whenever there is false, whenever the request 1 is false, there is a request from master 1. So we have to take the default value of these 3 ports as true. So to take the default value of these 3 ports that you have already defined in the structure, go to this, select the port, then go to the UML tab of the properties, and then scroll down. Here is the default value. Click this plus button and then literal boolean and true. OK. Now the request 1 has a default value of true. Similarly for request 2, select request 2, then come in the UML tab of the properties. Here is the default value. Click this button, then literal boolean, and then select true and OK. And the request 2 has also default value of true, and the request 3 also will have the default value of true. So here's the default value. Click this button, literal boolean, and select true and OK. Now these 3 ports have a default value of true. This is basically done in the structure. Now again going to the behavior from here. Okay, now the condition for going to master 2 from idle state is that there is a request from master 1 and master 2. There is a request from master 1 and master 2. So which means we have to trigger this transition on request 1 and request 2. But the condition will be on master 2. The condition will be from master on request 2. Okay. So to trigger it on the request 1 and request 2, select this transition, go to the UML section of the properties, then scroll down. Here is the basically trigger section. Click this button. Okay. Then port, and then browse for the ports. There can be more than one ports in the trigger. So in this particular transition we need 2 ports, that is request 1 and request 2. Then click this forward arrow button, and okay, now these both ports are shown here in the trigger. Okay, now that your trigger has been created. Now the condition that is there is that request 2 should be false. So click this button in the guard section, plus button, then add constraint, and then constraint element would be request 2, because ultimately this transition leads to master 2. So the master 2 means that there should be request from master 2, which means request 2 should be 0 or false. So constraint element would be request 2, because we have a condition on request 2. So click this plus button, then browse for request 2. Here is request 2. Then click this forward arrow button, and okay, and the specification would be literal boolean and false. Okay, false mean that there is a request from master 2. Okay, sorry. Okay, now there is another condition called as another transition which is going from idle to master 3, and this transition will be triggered on request 1 and request 3 port. So to add a trigger, select this transition, go to the UML section of the properties here, then scroll down, go to the trigger section here, click this button, then add a port from here, click this plus button, and search for the ports. And the transition and the ports on which this transition will be triggered are request 1 and request 3. Click this forward arrow button. Okay, now request 1 and request 3 are there in the port section of the trigger. Click OK. Now the trigger has been created. Now the condition, the guard condition, is basically on request 3, because the transition ultimately leads to request 3, so there should be a request from master 3. To add a condition, select this transition, go to the UML properties section, then guard, click this button, then add a constraint. It will then ask you for the constraint element and specification. Now the constraint element would be request 3. To add a constraint element, click this plus button, browse for request 3. Here it is, and then click this forward arrow button, then click OK. The specification would be request 3 literal boolean and then false. That is, request 3 should be false. Okay. Now this is basically a small portion of the behavior, and the rest of the behavior will be modeled in the next video. Thank you.